In a recent video, I looked at a neon ornament from eBay in the style of a pineapple, and I was really impressed because it used a hard plastic backing with channels built in, designed to take standard LED neon type material. And I was so impressed that I thought, well, I really like the shape of the rose one. I quite like the idea of actually making a larger scale one. And I ordered it, and it's got some notable differences from the pineapple effect. The route the connection takes is that it's terminated at this end with the incoming 5-volt supply. It's USB powered. It goes through, loops back, and then it goes through this section, loops back a bit, jumps over, goes up here, loops back, jumps over, and this is the important bit. It's actually looping back internally. It's actually using the LED channel as a sort of cabling channel as well. So all the links, if you look at, here's a short link, here's a short link, here's a short link. The longest link is here, but they've also left an option open for there. But they loop back and they keep doing that, including quite a long loop back here. And it just means it's very neat. It doesn't have much visible wiring. Not that the wiring is terribly visible, because it is ultimately clear sleeved, thin silvered wire. So it doesn't really show. If I turn it around like this, the prominent bit you're seeing is the LED neon. The other thing's notable about this is they've not used any glue. The stuff is literally just wedged into this channel, and you can lift it out easily enough. So for those of you who aren't familiar with LED neon, I have featured it in this channel a few times in the past. Let me just go over that again. So the material they're using here, I shall zoom down this, looks like this. It's a translucent mass. This is an end-on section of that. But it's a translucent material, but with actual solid white sides on either side. And it's got a channel inside with LED tape. And the LED tape, in this instance, because it's low voltage, 5 volts, it has bus bars in the back, but in the front it's got the solder pads, and then it's got one LED and a resistor, solder pads, one LED, resistor, solder pads, and you can cut it on those pads. It's notable in this instance that because they're fairly close, it's roughly half an inch, 12.5mm between LEDs, they're not being too discriminative about where they cut it. In fact, in some of these bits, they've cut it right on an LED, so it's like basically killed that section, but it doesn't really show. It shows as a slight dimming at the end, but it's not that you still get a lot of light diffusion in the material. But the idea of putting the light out sideways from the LED like this is that by putting that strip in sideways, it can't just shine out the front, because if it did, you'd end up with the channel, but it would have distinct dots of light along it wherever there's an LED. So what they do, they bounce the light sideways into this channel, and then it diffuses through this general diffusion material, and it produces, at the reduction of efficiency, but it produces this lovely soft diffused glow. I mean, you can see that glow here. You can't really see the individual LEDs too much. It looks a fairly linear line. And the interesting thing about this and the other one is that they have slit the back of it. They've basically made an incision here, and then they've peeled that apart, and they've soldered, instead of actually doing what many of the early signs did, instead of trying to just tack onto the end of these little pads, because they're cutting at a random position that could basically cut those off, or just because they don't give a strong connection, what they're actually doing is they're bringing wires in from the side, and they're soldering it once they've actually made that slit, and they're soldering directly onto these pads, which gives them a really big connection point. And it's notable, I've emulated that there as well with the side connection onto that with the front diffusion material. But it's notable that if you see a slight darkness at the end here, it's not that visible. The reason it's slightly dark there is because they've brought the cables in from the end, the actual solid cables that come from the USB supply, and they've soldered them onto those pads, but then they've actually crossed them right over that LED. If they'd made that hole just a little bit further up, they could have actually, it's almost like they've got a position for that. They could actually have soldered that in and actually brought it out the back, but maybe it's just the fact this is thicker cable, they didn't do that. So it's interesting, very interesting. It's definitely an evolution. It's neat how they're doing this. I noticed that certainly measuring this out, that it would work well with the 12 volt LED material. The 12 volt LED material can only be cut every inch, but the spacing of this is such that I reckon that, well, this is about 6 inches, so you should be able to fit in a 12 volt section. And that means that, well, it could be adapted to 12 volt for other purposes. It's easier to get the 12 volt stuff. I'm not getting that back in again now. This happened last time. It's because it needs squeezed. It's because my house is cold, probably. But it's an interesting twist. I really like that they've used that to hide that. Oh, another thing. When you get these, the back is covered in cling film or saran wrap. The reason for that is probably so that they don't get solder splashes on it while they're actually soldering these wires on, because it's very clear that the way they make this, and this is also where that losing some wire is going to be helpful, it's very clear that they actually, come to think of it, that would not protect the back, would it? Because if they are actually bringing this out to solder it, the cling film wouldn't protect the back. So they must just take extreme care when they're soldering it. Maybe put a little pad under that and solder it above that to stop actually getting splashes onto the plastic itself and marring the surface. But that extra length they've got there means that before they lay it in, they've got quite a large slack of wire, so they can pull it out, they can solder it easily, and then when they dress it back in, and I guess that they've probably got a bin full of specific lengths for each section, then that just means they can they've got that slack, but then they can dress it and hide it behind this. And it's really, the longest bit is here, where it's actually, from here, it's going on to that section, but it's actually then dressing back underneath the tube. And then going over here, and they've just lost about just over an inch or 25 millimeters here, probably more close to 30 millimeters in that. And likewise, they've lost a section there as well. It's quite neat. It's an interesting construction. It does hint that for smaller signs, you could 3D print a similar sort of guide frame, but of course that depends the size of your 3D printer. Mine only handles about 6 inches or 150 millimeters diameter, but that would still be useful for some shapes. But you could also print it as several sections that clip together, and then you could actually put this LED neon type material into it. But this is an interesting evolution. It's an interesting twist. I wonder if these were all designed at the same time and it just so happens that this one lends itself better to the short links, or if they've evolved the design, and I wonder if maybe the reason they don't have glue in this one is maybe it's a different production line, that they just decided they didn't need the glue. Maybe it's even a different factory making fairly identical units. But interesting stuff, and I have to say, visually, well, let me show you it in the dark. Let me show you it in the dark, and let me take this exposure off. Is this going to be too high? It looks pretty sharp. It looks pretty good. I like that effect. It's a very neat ornament, and it is adaptable. People like us can actually replace this tube light if it actually starts failing. Although, judging by the last video I made, I actually measured the current across it, and the voltage drop was high enough that the current through the LEDs is typically about 10 milliamps or less. So they all, although there's a high number of them, they all add up to a fairly decent intensity. But the total current for this is, again, less than an amp at 5 volts. It's about 800 milliamps. So I'd say the whole thing is dissipating about 4 watts of power between the resistors and LEDs. But it just, it's nice, and it is adaptable. And for us, as I say, it's serviceable. And things like that are kind of important.